Okay, part 2, after my internet is working again, hopefully. So I was trying to explain the equation. That's what I was trying to do. So stress here is written as any sort of typical observed variable would be in my equation, because stress as a box is an observed predictor. Yet another reason I did it that way, so I could make this contrast. And it has the same representation here in predicting symptoms. And mood here is also a level 1 predictor of symptoms. And this specifically is because of the way that I wrote the code. This is all of mood. This is not like the within person part, because that's why everything becomes contextual in M+, is because this is not just the within person part. In level 2, I have an equation for the mediator here, the intercept, and the slope. So this is for, this is for mood. So the mood intercept and the mood within person stress slope. And the intercept is loaded up with things. We've got age, gender, their interaction, person mean stress centered at 40, and then the random intercept here at the very end. The single term here is because why? Why is that all sitting there by itself? Is that correct, or did I forget some stuff? This is from the step 3 model, by the way, without the latent variable interactions. Question is this right, or should I have some more stuff in here?
We have no random effects of stress on symptoms.
Yep, that's what, so this is saying I only have a fixed effect of stress on mood, is for the M, at level 1. I don't have a random slope, and I don't have any cross-level interactions. So that's why this is empty. That's a choice. But again, this was enough as it was. Hang on here. Now the level 2 model for symptoms looks a little bit different than what we're used to. So I've got age, gender, their interaction, person mean stress as an observed variable, and then check this out. What's that thing? Beta 0 IM. I'll give you a hint. It's right there. It's the mediator. Yeah, it's the random intercept for the mediator specifically as a predictor variable. And note that it's the full thing, not just the leftover part. It's the whole thing. All of person mean differences in mood. The random intercept part at the end, it represents the idea of leftover. So yeah, this is a latent variable at level 2 predicting another latent variable at level 2. So that's what makes this different. These two are the within person slopes to the Y outcome, and they're both fixed as well. Okay, how are we doing? I wanted to show you what this would look like as an SEM single level mediation model instead. The reason that I did not do this the first time is because in this format, I would have wide data. Okay, so I've got 5 occasions, so I would have like 5 X's, 5 M's, 5 Y's, and stress is binary. So when I fit this model where I have a random intercept latent factor predicting stress so that I can partition its variability in the same way as the others, I then have to tell it that they would be that it would be binary. So this is actually a generalized version of a structural equation model. So to do that, first thing I had to do is restructure the data, so long to wide to get it into the wide format that I need. So it's going to take what used to be one variable for stress and turn it into 5, do the same thing for the other two sets. I tell it what the occasion indicator was previously, so this is the last 5 days of the study. The names is what the variables used to be in the long data. Use variables is what they are now after being transformed into wide data. And then categorical equals stress 1 to 5. So that is fitting a logit version of this model to predict binary stress as an outcome. Conditional Bernoulli distribution and a logit link function. To do this, so then in terms of setting up the level 1 model, I have to shut off all of the information about the original variable's intercepts so that I can push that up to the random intercept to have a fixed intercept and a random intercept variance around it. For stress, though, I have these dollar sign thingies. SEM folks, what does that mean? It's like a cross-collaboration event here with our classes.
I mean, it would be a threshold.
Yeah, it's the stupid threshold. It's back. And yes, I always have to say it's a stupid threshold. I can't ever just say it normally. This is, a threshold is the opposite of an intercept. So an intercept would give you the predicted logit of a 1. Thresholds give you the predicted logit of a 0 instead, and that's the way M+ does it for better or worse. You can multiply one by -1 to get the other. So we're shutting off all of the information about the means of these variables. We are holding constant the residual variance over time. That's going to become a constant level 1 variance, just like it was in the other model for mood and for symptoms. Then I've got my 3 random intercept factors. So f of x int, m int, and y int, each defined by their observed variables with loadings fixed to 1. So that's my random intercept factor. Each factor has an estimated intercept because that is going to be its fixed intercept that carries the average for the variable over time. And each of them has a random intercept that's been estimated instead. Then I have my level 2 fixed effects. So age, gender, and the interaction predicting y and m as in the previous model. Here's the mediation part. These are still contextual because of the way that I've set it up. And then I have level 1 direct fixed effects for the indicator at that occasion to the other thing at the same occasion. So PON means pairwise on. Like 1 predicts 1, 2 predicts 2, 3 predicts 3. And the fact that I put a label on the outside of them here means that I'm asking for all 5 of those within person slopes to be constrained equal across days. So it's consistent with the other model. So this is both a label and a constraint in this context. Then I can get my between effects as before, and I can get my indirect effects as before as well. So this is not an equivalent model to what we did in long form because of the way I'm treating stress as an outcome and not a predictor. But that was the better way to do it, I thought. So I wanted you to have an example of what that would look like. Yeah, so then we get to all this new stuff. In this version of it, the output is not divided into between within, so you have to do a little bit more detective work to figure out what's what. The first set of things here, these are all my level 2 relationships. So the intercept for x predicting the intercept for the mediator, not significant. The intercept for the intercept factor, let's put it that way, the intercept factor for x predicting that of y, that's a contextual effect and that is significant. M to y was also significant. This is the one that's different though. Then the covariates predicting the intercept factor for y and for m. And then here are the pairwise within person slopes that I constrained to be the same. So they're all the exact same number with the same standard error because I told it to do that. This is also an empirical question as to whether your time varying effects might grow stronger over time or weaker. Here are the same patterns for the relationships between stress and symptoms and mood and symptoms as well. So we can compare the difference in what we've found relative to the previous effect of stress being observed. And it looks like, so the big differences would be anything involving the x variables, the contextual effect of, here it is, x on y is 0.264, but previously the contextual effect, oh, I don't have that one, of course I don't. Let me get the between effects, that'll be easier. 194 versus 0.286, so a little bit different in this case. Observed versus latent should make a little bit of a difference at least. But I think largely the story is pretty much the same. There, I can't scroll anymore. That means I got to the end of the handout. Yay! Yay me. All right. Going back to the top of the handout here. So foreshadowing where we're headed next, which is not happening today, even though I did get the lecture 5 done. Each of these variables, I am assuming right now, does not have any change over time. And because I know these data and I used them in chapter 8 of my book, I know that to be true. But that's an empirical question. So what this story is missing potentially is another set of level 2 variables that would represent between person differences in change over time, right? I could have a time slope for how stress changes across days, for how mood changes across days, and how symptoms changes across days potentially. And if I had that, then I have another set of 3 constructs in here related to change over time that I could have relations with as well. So in the example that we're going to do next week, it's the same type of story, except that the 2 outcomes here and here each have individual differences in change. So the model necessarily gets more complicated because we have to separately allocate variability due to individual differences in change as yet another set of latent variables. Cool stuff, huh? I think so. All right. Questions or comments? No? Zoomers? No questions or comments right now? That's fair, because it's Thursday and it's 1:40, so we can end 5 minutes early, right? I'm not letting you down if I do that? Okay, that's a long-running joke with my husband and I. It's like, no, the kids don't mind if you let them out early. So, I will do that. Let me know if you need anything. Otherwise, have great weekends, and I will see you next week. Thanks for being here. Thank you, Zoomers, as well.
Thanks, Lisa.
Your mind is blown. I'm going to take that as a compliment.